Okay. Hello? Hello? Just sitting on? Full cam? Okay, there we go. Oh, we need some lights. We need lights. Running a little bit late today, but that's alright. Just a chill stream anyways. Let's see here. Turn on the left light. There we go. More even, balanced lighting for green screen. Green screen. This is very intense music, dang. Okay. So, let me see if my circuit cam's working. Because I need to recap where we were last time. Is this one? There we go. Also need to get the framing right. Okay, it looks like it got moved a little bit. There we go. Circuit. Circuit is back. Been doing some off-stream stuff with the circuit, making waveforms come out of these wires onto an oscilloscope. But the scope of this, I'm gonna put the code back on for the alarm clock because we want to make it so the alarm clock can actually function with a timer. Right now it just shows which button is pressed. You know, not quite a timer, but more of like whose turn is it, that kind of thing. It looks like that. So let me load that up if I can find it. Here it is. Just need to do cargo run. Also make sure there's power on this thing. It's recompiling. I'm surprised it needed to compile again. Okay. This is what it initialized to. I press button. Do nothing. Do nothing. Interesting. What if I reset it? Interesting. Interesting. Nothing is different. This was not how it was before. Interesting. Probably because I need to put this wire back in. Watch this. There we go. Yep. I was using these wires for the oscilloscope feature of this tool, so that way I could see my audio signal when I was working on audio. Okay, so you press the button, it toggles. Whose turn is it? Boom, 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 boom. Easy enough. So the real key to getting what I need is to have some function that's called whenever we count down. Let me show my code screen. Is it this one? It is this one. Right, okay. So last time we hard coded the segments of each of those displays, and there's also this bug that we're gonna need to figure out. While it shows a 1, it has a negative sign. Not really sure why. Could be a wiring thing, but what leads me to think it's not a wiring thing is because that should be popping up on the bottom here as well, right? It has to do, I think, more with the software. To me, this seems like a software bug. So I'll have to figure that out too. Could be like we're running it too fast. I could always just like slow this down to maybe, I don't know, 1 hertz. Wonder what happens if I do 1 hertz instead of 10 hertz. A kilohertz, that is, not 1 hertz. In kilohertz. Yeah, it looks like it's the same. So it's not a speed thing. It's a code thing. So one key thing to Embassy is that you have your main executor, and that you need to have your other threads, you know, your not current context, but your other functions that you want to trigger at particular times. You have those in separate threads, essentially. Right here, we main spawn it, but I'm going to open up a window here of example code. And they're going to make it bigger. I think it was this framework. Is this the one that did it? No, it wasn't this one. I think it might have just been Embassy's main thing. They have this example. Now let's say test bench. This is just async. There's just async programming in Rust, period. That's not quite what I'm looking for. There was... Oh, was it this one? That's the library. Real-time ready. Example. This is it. So this one, it shows how you can create different executor instances to spawn at particular times. So, let me zoom in. Get rid of that. Is this written for the NRF? I think it is, yeah. Even though this is for a different chipset, Embassy is cross-platform enough or similar enough between the different chips that it's not really a change of how the code looks, which is a really huge plus if you want to develop code for multiple platforms. But here it looks like they have a software interrupt that gets configured, and they're setting its priority level so that way it can see higher priority tasks, since the executor looks more like a scheduler. So let's see, it's making this interrupt based off of software interrupt 1. I'm not sure what EGU stands for, but this is just like one of the software interrupts that the NRF had, and it's making it a high priority. That's gonna be called spawner. And this unwrap, this is a macro that makes it so the return of this function, because it returns what they call in Rust a result, which means that it tests if your function passes or fails. They use the word, I think, error and OK. So unwrap just means that if you get that error case, the program just freezes or goes into infinite while loop. It panics. And so you don't have to write logic to handle the error case. And so they use that a bunch. So anyways, they spawn that spawner thread, and they want to call the function run high. So this is a thread, it looks like. It gets triggered on a software interrupt, and it calls this run high function, which I believe is written up here, yeah. And this is a macro using, or just describing that it's a task. And this run high has an infinite loop that loops until a certain time. So this one's more based on software interrupts. Is that the way we want it? That I'm not sure. That I'm not sure. It looks like they do similar things for these two, except you're not using the unwrap, you're using a different method for this, and maybe that's just the way you do overflow prio stuff. Using WFE/SEV. Secure executor. No, I'm not too sure what these acronyms are for. Looks like these ones are tied to hardware, those ones aren't. Maybe I should read the comments. This one might tell me. Low priority executor runs in thread mode, not interrupt mode, and uses SEV for signaling. There's work in the queue, and WFE is waiting for work. Medium and high priority executors run in 2 interrupts with different priorities. Signaling work is done by pending the interrupt. No waiting needs to be done explicitly, since when there's work, the interrupt will trigger and run the executor. Example output below. Essentially that. For comparison, try changing the code so all 3 tasks get spawned on low priority executor. You will get an output like the following. Low, your high, you tick, your medium starts, your low starts, your medium goes back. Your context switching, because they're all even. Whenever you get a new instance, it looks like it just tries to do that. Whereas this one, if you have higher priority, you don't get interrupted by the other task. Because I think you call it particularly, you call it in highest priority, medium, low. Let's see, this one's done. Wait. Done that much time, done in that much time. It's actually going after ticks. What if I look at some examples that were specifically using timers? I think that might be the key here. We essentially need to see where we can utilize the timer library to make some of this. But I don't know if any of these have examples. This one's writing to Flash. No, it's not that one. The I2C, is that gonna have? It does have an interrupt. Looks like it's binding some interrupts for the I2C. I just know it's tough due to this time library. I wonder if there's any examples specifically tied to that library if I go to the embassy-time folder. Doesn't quite look like that. What's the difference here? Instant represents a given instant of time relative to system boot. So how many ticks essentially since you powered on a device and booted. Duration represents the duration of a span of time. So this is between 2 different time points. You can do probably a start and then you do a stop and then it'll tell you how long that's been. This, let's see, instant is like if you wanted to see something get checked after like 1 minute or 1 second since boot up. Duration might be like, I want to see how long it took me to do these 2 things. Like I hit start, I run a lap, and then I hit stop. So does that work for what we want to do? We want to check. We want to check more of like, has it been a second? If so, subtract 1 from our timer. So I don't think this is quite the keyword I need. Delays and timeouts. Timer allows performing async delays. Ticker allows periodic delays without drifting over time. Okay, I think this might be what we want. An implementation of the embedded HAL delay traits is provided by delay for compatibility with libraries from the ecosystem. Ticker seems to be a strong contender. What about this? Wall clock time. The time module deals exclusively with a monotonically increasing time count. Therefore, it has no direct support for wall clock time, aka real time. So this is dealing with time, but since boot basically still. If persistence across reboots is not needed, support can be built on top of embassy time by storing the offset between seconds elapsed since boot and seconds since Unix epoch. Yeah, this is like getting, as it says, the wall clock time. So if you want to see which date it was, what hour was second, yeah. I don't quite need this. I need a timer, but in reality, the implementation we want is probably going to be this ticker-based one. Okay. What is this? Timekeeping is done with the elapsed time since system boot. Time is represented in ticks. That makes sense. When the tick rate is defined either by the driver or chosen by the user with a tick rate feature, the chosen tick rate applies to everything in the embassy time and thus determines the maximum timing resolution of 1 divided by tick rate seconds. So maximum resolution. Do we want this thing checking all the time or just some of the time? If we open up, let's see, do we have anything here? We'll piggyback off of this. Let's see if I can turn on my drawing tablet without any issues. I should have charged it. Okay. Let's get white, and let's also change this song because I don't really think it's fitting the mood. It's not more chill. Okay, seems fine. All right. So we got the equation 1 over tick rate is our maximum. Was it rate actually? Hold on. What was it? Our maximum timing resolution. I'm gonna just say resolution. Howdy, welcome back, architect. It's been a little bit. Where's that sine wave we're looking for? Okay, we got our clock here. We need this to update every 1 second. At the very least, our tick rate needs to be 1. 7 segment displays be like, yep, that's right, -1. Not really sure why it's like that. That's a bug I'm gonna have to figure out, but we'll get to that in a bit. For now, I'm trying to figure out how to make these be an actual clock, you know, counting up and down. We want to represent that. Okay. So this tick rate, we can have tick rate TR, we'll call it. We can have it be 1, but that's not super efficient. If you do it as 1, then it does count every 1 second. The issue is, because we're using this for chess, we want it to be at least refreshing more often than that. Because when people are moving chess pieces really fast, you know, there's a point at which you're like, make a move and then you press the button, then you make a move and then you press the button, then you make a move and you press the button, and you're just like, you know, going back and forth, 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 right? Until eventually somebody runs out of time. That can happen way faster than 1 second. So realistically, I don't think, like, if we want to be safe, you for sure could have it happen every 1 millisecond, which means that we have a tick rate of, I want to say, actually, hold on, maximum resolution. This is how many ticks per time? Hold on. Maximum timing resolution. Oh, seconds. They're saying it's seconds. Okay. aka seconds. We'll do that. Okay, so back to it, right? This equals 1 second. If we're gonna do 1 millisecond, we need the tick rate to at least be, I think, 1,000, which is the same as 1 kilohertz. So this would equal 1 millisecond, right? Easy peasy. 1 millisecond. It would allow us to move really fast because I don't really see anybody moving faster than 1 millisecond. One issue that could arise is that these buttons, they have these like in between times where if this is a graph, right, this is 5 volts up here, the button can be pressed down and then it gets grounded. But in terms of how it gets read, like we're grounding it here, the chip might read it and internally it might like bounce a little bit before it stabilizes, and we call this like debounce region. Plus 5 volts, right? Debounce. And at least when I was first learning this stuff, you debounce, usually you handle it by the instant at which you see what they call a rising edge. So your signal goes positive. The instant that happens, do a sleep for like 20 milliseconds, let's say, where you just ignore all the data, all the sampling it could happen. Your processor does not check back to see what the value of your button is until afterwards, and it looks stable. Analog voltage looking what? How's it going, Gabriel? Audi, welcome. Yeah, so like this delay you can put, this is one way to handle debouncing. A different way is you can use a circuit where you tie what they call a capacitor to ground with your button. So if your button's here, you can, oh, is this the circuit? Let's say you have a plus 5 volts here, and this is your microcontroller. Then this capacitor kind of like smooths this out top. What does top mean? Yeah, if you were to use the capacitor, it would change that kind of signal into something that looks more like this. Just less spikes. You're rounding it out. So that's the like circuit way you can solve it. You can use software or circuits to solve this kind of debouncing issue. You're as efficient as optimized. Why did you type for him? He doesn't want to share it himself. You're quoting somebody else. You're as efficient as optimized embedded code, running smoothly and seamless. I can't speak seamlessly. I appreciate that. He's at your house. Oh, okay. That makes more sense. I see. Having a study group. Okay. This could become an issue over time. We'll have to see what behavior is like. I think for now, I'm going to try this 1 millisecond tick rate. Because it makes it a little bit less demanding. You could have way more bits. Default tick rate is at 1 megahertz. Jeez, that's way faster than any of the ones I was going to use. I was using 1 kilohertz. This is 1,000 times faster than the sample rate I was using. If it's defaulting to that, I mean, for sure we'd at least see our issue, but I just need to do some logic where I'm counting. Let's see. If we're updating our clock, we're updating our 7-segment display. Updating this, right? Every 1 second. Then, and we have 1 million counts per second. We need to see, we need our clock to do that. College area, I'm in the US, SoCal, but I'm not in college anymore. Okay, 100 megahertz, or 1 million megahertz. No, 1 million megahertz would be way larger. This is just 1 million hertz, or in other words, 1 megahertz. Okay, anyways. We should figure out how to just make it a lot easier. Actually, the key to these usually is pulling up the documentation. So let me get that up. I think it's this page. Then you go to documentation. Oh, flashbang, not that page. Is it this one? It's just gonna, yeah, here we go. And do we get to choose a chip? This page doesn't have a chip select, but that's fine. So this was the same exact thing. What's happening right now? Basically, this is an alarm that I need to make tick down. Right now we have 2 buttons and it indicates which turn it is if you're playing chess. So one person makes a move, then they hit this button to indicate their turn's done. Then the other person makes a move and they hit this button. If you've ever played chess, or you can look up chess, I'm making that, but using Rust to code this chip. And then we're gonna put it all together in a nice little box that's much more small. But that's gonna be down the line. Okay. So this timer crate, at least that's what they call it in Rust instead of library, this crate. We want to find this implementation of this ticker struct. And here's an example they did. They created a new task with this hashtag embassy executor task. Okay, thank you, Ann Kimball. So, they made a function here that's asynchronous, which means that it can be ran at any time. It doesn't know when it's going to be ran. Async is just a keyword in Rust. This can be ran at any time. And when it does run, they're using this random foo. This is just a random function they're using for this example. But then they're doing this delay for 1 second, where they say, okay, for a duration of 1 second, I'll wait until after 1 second has passed. This is one way of doing a delay. I think that's the old-fashioned way, though. I think this library got updated to be much more straightforward, and it looks like they use it here. Simply remarkable. Wow, thank you. Thank you so much. Okay. This is a similar start point. They have a variable called ticker that's mutable, meaning it can be written to. This is our crate. We're calling this function called every from this creator library, which is imported here. And we're saying every 1 second, set this variable to something. This is exactly what I needed. Because for every 1 second, we want our clock to go down. We want it to decrease. So this is a quick and dirty way of doing that. And they initialized this variable, but it's only ever like rechecked in this loop here. So I'm gonna try that out. Where we go to our code. This is gonna go, we're gonna delete this. And hold on, let me make some space here. Gotta move my keyboard over since I was drawing. All right, we want to import. I'm gonna put this back at 10 hertz actually, 10 kilohertz. We want to import the ticker thing, just like it says here, which we could actually kind of just copy that essentially. Now I don't know if you, there's a like a design pattern or a way people usually do this. If you put your main before your other executors or not. We'll just have to see. So embassy executor, we're gonna do a task. Well, actually, what are our options? We have task or main. Yeah, we're doing a task. And this is gonna be an async function. 100 bits. Dang, thanks for the bits. You are officially the first person to ever cheer any bits. Appreciate that. Okay, thanks, Ken. So we need to put, I typed 100. I got so excited I saw 100. So, okay. Do we want to call this our alarm? Probably our counter. We'll start with our alarm counter for now. Yeah. And see, we can rename that later, but for this sake, we're fine with that. So we're gonna call this thing, we called it a ticker. I don't know if I want to keep that name. We essentially just need this thing to just be called. This is just a delay that is reoccurring. It'll always happen over and over again. Whereas this one, they recalled it every single time. This one is just a variable to take care of it. This one waits for the next tick. You can reset it back to its original state. Ooh, this is actually, this is why you would use it now that I'm looking at it. So we have 3 different options. Up here, they said every 1 second, call it, which is just always every 1 second. But there's some times when we press this button, we don't want to call it. We don't want it to decrease because you could be, actually, well, okay, if you're being truly accurate, you make it where it's in the milliseconds. Yeah, maybe that's what we do. Even though we have 4 digits here, where's my pen? Even though we have 4 digits, we might have some ghost values. Right? 1, 2, actually, let's do this, right? You have 4 minutes and 59 seconds left. Every single time we are on this person's turn, we want it to go down while this person stays at 5. Oops. But there's times when people press the button. There's times where people press the button in between those seconds. We already talked about that with the milliseconds. Like, let's say we hit the button right here. So then we now go to 4:56 or 7 here, and this one goes down. Right? I'm trying to think, do we want this to, our counter to begin at 1? Or do we want it to begin at, let's say, 0.01, like 10 millisecond counter? Because if I go on to chess.com, I feel like... Hold on, where's it? Chess timer. Chess clock. I feel like if I go here, it's going to go into the milliseconds. Like if I go 1 minute. 1 minute, spacebar, time difference. This is fine. Understood. This is counting down. I mean, this is essentially what I want to make, right? This person's going, you click this person. I wonder, oh, hold on, I had an extra setting on there. 0. There's this rule where if you finish your turn, you get extra time added, 5 seconds added on. I'm curious. So, you see how I am clicking very fast? This is the back and forth problem. If I only counted every 1 second and reset that 1 second timer every single time it was that person's turn, it would never decrement if you clicked the button faster than 1 second. Like, if I were to, let's say, hit the button, let's say this is 1 second, right? You have 1 second. 1 second to hit this button. If you hit it here, then all this time just gets thrown out. You need to... yeah, all this time gets thrown out because you set a rule saying if you like reach, if a full second passes, then you decrement. Decrease count. But if you were to hit this button anywhere in here, you don't actually reach that 1 second time. So in reality, you need to, instead of counting, you know, by seconds, you should be counting probably by, you could honestly just do 1 millisecond. That's fine too. And every 1 millisecond is actually each of these dots. So you're constantly sampling to see if the button was pressed in any of these times. And if it was pressed, then you pause time. Right? If your button was pressed here, you now know that you have this much time left before I don't know, this is like 0.7 sec. You have this much time left before, you know, update display or update the timer, that kind of thing. So we'll do this, or even finer tuning than that. So that example they had it doing for every second. We're gonna do every millisecond. Simple enough. And better yet, why don't we name this like something that we'll know? Milli. Can we do numbers in Rust? And variables? Looks like it. So ticker 1 millisecond, or in fact, I might even do underscore there. And I believe, what do we need? Every. So it's not showing me anything because I didn't import it. I need to import it from the embassy IAM library. Is embassy previous timer. And we need to update our